Good evening, everyone. So we have few people on the call. So we just plan to start this at 6:30 p.m. India time, and we will start on time. And I'm recording, so it will be available later point in time. So just in case somebody who's joining can always watch it, listen the recording. All right. So I want to welcome you to this Kubernetes session, and I'm gonna talk through Kubernetes via Azure Kubernetes. And I have done few videos on AKS or Azure Kubernetes Services in terms of how you can create and control the Kubernetes from Azure Kubernetes and then deploy the cluster. And I'll point you to those resources in terms of how you can create those clusters. It takes some minutes, so I wanted to skip that creation process, but you can always watch my video, which is always available in YouTube, and can see how you can create the cluster. But it's pretty much simple. So to start with, what I'm going to do is that I'm going to first show you the portal experience, how Azure Portal looks like when you start working on Kubernetes. So I've got an Azure subscription. So let me open that Azure Portal over here. Let me take you to that. Okay, so this is my Azure Portal. Now, when you go to the Azure Portal, you need a resource group to start with, right? It's sort of like a blank folder. Now, when you have the resource group created, right, and it is like sort of a container, and inside that container, you go ahead and create everything you want to create. So I have created a resource group already, and the Kubernetes cluster, which I already have pre-created, takes few minutes time. So I will show you that experience, how that looks like, but I will not create it now. Okay, but I will show you that portal experience. Now, when you do it for the first time, you use Portal, but going forward in the real DevOps scenario, we don't use Portal to create any AKS cluster. We always use some sort of script. Either it could be a Terraform, it could be Azure CLI or PowerShell, or infrastructure as a code model, right? So that's how we should be considering while we deploy any infrastructure resources to Azure. So either you could be Bicep, right? So which is the modified version of Kubernetes. So now you can see that this is the Azure portal. Now it gives you an ability to create many things. If you know where that belongs to, you can literally go there and start creating the Kubernetes. So this is the Azure portal I'm showing you now, which basically has got all the things. So I have created this ARGAKS resource group, which is basically an empty resource group if you do create it for the first time. And then if you want to create anything inside that, you can either click on plus this create icon. And if you say so, it gives you all those 100 plus services you can create in Azure. Now I will be creating Kubernetes, so you can typically go ahead and search for Kubernetes service, okay? And then you see the options available for you to create the Kubernetes service. So you have got this marketplace concept in Azure, which allows you to choose what you want to create. Now you choose this, create, right? And this will give you a wizard experience. So this is good for the first timers or the newcomers. But when you really deploy something on the real, let's say, production environment, you must use something like infrastructure as a code, like it could be a Azure Bicep, which is the modified version of the ARM template, could be Terraform, could be Azure CLI, could be PowerShell, so on and so forth. So whatever the preferred choice for you to write code to deploy infrastructure, you should be using that, not this environment. But just this gives you all the options you may get while you create a cluster. So that's why it is important for me to really walk through this, but I'll not create the cluster because the cluster is already created. So what I'm going to do now, I'm going to go ahead and it's already selected and the subscription is selected. And then you can see that it tells you about the preset configuration, right? So this talks about some of the settings which you may or may not have. So let me just put a name, okay? Just a name that will. And then once you have the name, you can choose which data center region you want to deploy this cluster to. So depending on the customer and the data you need to stick to, you choose that data center region. So if you, let's say, work in APAC region, you will choose Southeast Asia, which is our Singapore data center. So it'll basically land in one of the data center buildings in Singapore City. So you can see here, right, so that Southeast Asia is closest, and you can also use the availability zone, which gives you more SLA. And if you choose to select all the three availability zone, depending on the region you select, the availability zone may or may not exist. So for example, for me, the Southeast Asia has availability zone, so that's why it is showing up. If you choose a region which doesn't have an availability zone, it will not show up. Okay, so don't worry about that. If that availability zone is not showing up, it's mainly because you do not have that. I'm not going to choose that, so just because just for demo, so it's okay. Now you can see that it gives you a couple of options, right? It gives you a couple of options in terms of like what are the different Kubernetes versions we can select. Now, some of them looks like a preview, some of them selected as default, and you can go down up to 1.19. Okay, so you can easily understand from here is that because Kubernetes is an open source technology, we use the upstream Kubernetes, which means that the Kubernetes which is available for anybody, you can go ahead and download from GitHub, download the Kubernetes, build your own cluster, so it's all free for you. So we use the same Kubernetes to run the Kubernetes service. But when we use in Azure context, because it is a fully managed service, we also own the responsibility of maintaining and running it for you. So we need to test it. Now you see that we strive to stay up to date, always with the upstream version of the Kubernetes. So today, whatever the version is, within few weeks or days, you will see that it is available in the list for you to pick up. Now you can see that it is showing you as preview. It's mainly because Microsoft probably is still testing it out on the Azure's context. So it's a bit of caution for you if you choose this, that it is not yet fully, let's say, recognized from Microsoft. But this is the upstream latest Kubernetes, and you will find always Microsoft is pretty close to whatever there in the upstream Kubernetes. Now you always can go by the default one, which is, let's say, n-2. So it is 22. Minor version is 22. So the 20 is the n-2. So you can say whatever the latest n-2 is, that is the default one. Okay. So you choose that. So it's always to be on the safer side. In the production kind of scenario, you get the best performance or best reliability if you choose the n-2. Okay. That's why you see that it's identified as default. But no one is really stopping you not to choose the latest one. Okay, so you can do that. You also have something like a size of the virtual machine. So when you build a Kubernetes cluster, it builds a couple of, let's say, virtual machines and creates a cluster out of that. Now, one of them you can consider on a simplest term is what we call as control plane. That's the heart and soul of Kubernetes. That's what Microsoft manages. So when you go ahead and select Azure Kubernetes Service or AKS, you basically get the fully managed Kubernetes. And the heart and soul of the Kubernetes, that's the Kubernetes control plane, which hosts the database for Kubernetes, which hosts the API server, the authentication, the certificate server, everything you need to run Kubernetes is managed by Microsoft, and you don't get to see that machine. Okay, so there is a machine available which shows that, but you don't get to see that, neither you can remote into that machine. What you get to see are the worker nodes. Okay, so if you look into the typical high-level structure of the Kubernetes, if you see the Kubernetes structure, it looks like something like this. So you have got this big control plane. Okay, that's a control plane. And there are a bunch of machines which forms sort of like a worker node, right? So this is worker node 1, worker node 2, worker node 3. And they all connect. Now you can increase the capacity by increasing the worker node, more and more worker node if you have a very busy Kubernetes cluster. Now these are the worker node we are talking about by mentioning the size, and we call it as a node pool. Okay, so what we have selected over here in this wizard is the size of the virtual machine I want to select. So there is a default size already selected. If you want to change, you can change it. So that's the whole point I wanted to make. So you, depending on the type of work you are doing, you can choose different kind of virtual machine size. For example, if you're doing a lot of, let's say, image rendering and analysis kind of activity, where you have a lot of graphical activity happening, you can choose the N series. That's a graphics heavy workload. You can run a lot of algorithm, image analysis algorithm, deep learning algorithm, all these things in this kind of series. If you are dealing with, let's say, a lot of in-memory activity, so you can choose the virtual machine family which deals with a lot of in-memory activity. D series is typically general, right? So general purpose, most of the workload can run on the D series. So you can see that it is choosing the D series. DS stands for general purpose, but SSD kind of disk, so you have a faster experience. So you know that when you use laptops, right? Laptops with hard disks with SSDs are completely different experience, okay, with the same configuration. So that's what it is here. And then there is an auto scale option available, and this auto scale option is for the cluster auto scale. So what happens when you start with, let's say, 3 node cluster, and then you increase the capacity later point in time, let's say you deploy a lot more application into the Kubernetes cluster, then you need to increase the capacity of the cluster because your memory and the hard disk size is limited. So you can increase the number of worker nodes in the Kubernetes by increasing this number, and you can do it either by manual or automated way. So you can choose both the options. So this is also a great thing about Azure Kubernetes. You don't need to take down the whole cluster. You can keep adding the worker node just by saying the number, and it will do all the heavy lifting for you by deploying the full thing and then connecting it back to the control plane. Now this is where it talks about node pool. Now there are a couple of different kind of node pools you can add. The default one is the system node pool. So system node pool, as the name suggests, is mainly meant for system centric activities like your control plane, like all these things. However, you can still live with it, right? You can have the system node pool added and then build your worker node on top of the system node pool. That is absolutely fine. There is no harm doing that. However, if you have a specific kind of node pool you want to connect to, and you want to say, like, I want to, let's say, host Windows container based images, the images which are Windows based, legacy Windows application needs Windows container. This is a Linux operating system, so system node pool can only have a Linux operating system, but you can add node pool with a Windows operating system, and that will be the user node pool, right? So you can see that it is user, and that allows you to choose the node pool. So I can say win pool, okay, and then I can choose the different kind of options available things, right? So you can see that there is a little notification showing up here saying that Windows node pools are not supported on KubeNet cluster. What does that mean? It means that when you select a Kubernetes, right, you choose a networking solution. What is the networking solution? If you choose the KubeNet, which is a open source Kubernetes networking solution, it allows you to have the networking in place with the default settings of the KubeNet. However, when you are in Azure, You can also leverage the power of Azure Virtual Network. And if you choose that, then you will be able to build the Windows node pool. I did not select the Azure Virtual Network, hence this Windows node pool option is grayed out, and that's why this notification talks about. Okay, we're not going to go into that, but there is an option for you to really build a Windows container on your Kubernetes, right? So that's what I want to show. If you notice here, like you have a couple of other options, we'll skip through that, and then we'll go to the authentication. Now there's also something which you get additional in Azure. That means you have got Azure Active Directory, you have this RBAC options available, that's role-based access control, which lets you choose the fine-grained access for different kind of users. So if you have a user who is an admin, will have complete control of the Kubernetes cluster. Somebody who is just a developer or DevOps engineer will have a very limited access to this Kubernetes cluster. So you can select the kind of people you want to allow and what the role they play. Based on that, you group that. So you can enable that, right? So that's a kind of thing. And you can also say that I want to say Azure Active Directory, which is the primary authentication system. So it will not use the certificate. However, the Kubernetes as an architecture, it will always use certificate, but they'll be mapping with the certificate between the certificate and the Active Directory user happening for Azure behind the scenes. So you don't need to know about it, but that exactly happens behind the scene. Now you see here, you go to the networking side. That's where we were talking about, right? That's why it was not allowing you to select the Windows node because it is default selected as KubeNet. So you can choose the Azure CNI. That means the Azure CNI plugin, which requires you to have an Azure virtual network. Okay, if you choose that, then you'll be able to create a Windows node pool. Okay, otherwise you won't be. The reason why you need the Azure Virtual Network for the cluster for Windows virtual machines. Okay, we'll skip that. And then you have a couple of options. The pod networking, you can use Calico or Azure. So if you choose the Azure CNI, then this Azure will be enabled. If you don't choose, then it's disabled. You can see that it's grayed out. So Calico is another open source based third-party solution for pod networking. So you can choose or you can skip it now. So for this, we don't need any of this additional advanced stuff. What we can do, we can now go into integration. So integration talks about if you have a container registry and you want to treat that container registry as a private registry, which essentially means that you need to, let's say, log in to download the container images from and then deploy it in the container Kubernetes. You can associate that. You can do it later point in time. So there is Azure CLI command available, which lets you connect between the Azure Kubernetes services and Azure Container Registry, which is another service in Azure, which probably we'll talk in our upcoming session, not now, but there is an option available to pick up from the list if you have any. Right now I don't have any, so you don't see any of these things showing up over here. Now, having said that, you have this option of monitoring, right? So do you want to really enable the container monitoring? And then where do you want to save the log of that monitoring activity, etc. You can configure, right? I want to disable it, so you can say disable it. I don't want to monitor it. Let's go ahead with that. But in production, you need these settings to be applied quite effectively, right? Now with this, if I just click now review and create, this will make sure that all the things are tested, and it will just allow me to create once everything is validated and nothing is missing. Whatever the default value I need to pass or the mandatory value I need to pass are being passed and available, etc. I can go ahead and simply click on create, and that will create the cluster for you. There is nothing you need to do from now onwards. So that's what I've already done to save some time. Okay, let me go back to this. I am not going to create now. So I'm going to go back to this resource group, where I was, and I have a cluster created. So once you get the cluster created, you see this kind of icon, right? A beehive kind of icon. That's the Azure Kubernetes service. And inside that, you get a lot of options, right? You have a menu in the left-hand side, which talks about various different properties you can look for. And then you have got an overall picture, the summary of what is there in that. So it is saying that the Kubernetes version is 1.21.7. Okay, that's the Kubernetes version, that runtime version of the Kubernetes. There is an API server DNS endpoint also available to us. And then network is KubeNet. You could see that I'm not using Azure Virtual Network. That then otherwise it will be shown up as Azure CNI. Okay, and then I have a one node pool. By the way, in a Kubernetes cluster, you can have more than one node pool. So there's a limit to it, how many node pools you can have. So, but you can have more than one node pools. So you can have one Windows, one Linux. Pretty much you can mix and match and deploy Windows workload to the Windows node pool and Linux workloads to the Linux node pool. So you can have those multiple different options available. Now you have this little bit of networking information available, which talks about what is the subnet range and all this stuff like DNS IP address, an API server, Docker, because it uses Docker runtime, so that is a Docker bridge, all this information. So this is just a FYI kind of thing. So we don't need to know or change anything over here. If you have any doubt, any query regarding what is happening behind the scene, you can always come back and then get more details about it from this dashboard, right? It also allows you to do a little bit of monitoring, right? It talks about the health of the cluster, right? So it shows you how many CPU, like how much CPU is being used, right? So you can say it's like 5.9%. It's pretty negligible at this point in time because I don't have any workload. You can even see that networking is also pretty limited in terms of like disk storage, etc. So I'm pretty good at this point in time with my thing. Because I don't have any workload, there is nothing actually happening within those worker nodes. Now let's see how I can use it as a cluster. So when you start working on application deployment, you will probably have this cluster already built and set up for you, right? So in the typical enterprise scenario, in the typical application development or DevOps scenario, this cluster is a one-time activity. So it happens only once. And then you just point to that and then start deploying your workload multiple times. So that's what the goal here is. So how do we connect to this? Now, just like any relational database management system, you have a central database server and then your databases are created within that. And you can connect to that relational database management server from any machine if you have the network connectivity allowed. Okay, that means that you are allowed to connect using a public IP address and blah blah blah. You can actually do that from your own machine to connect to a remote database. Similar to that, you see here there's a small utility helpful utility available, which tells you that there are a couple of things you can identify. One is that there is a command which is an Azure CLI command. So anything which you see AZ, AKS, it's Azure command line interface, Azure CLI. Now you can run this from two different places. One, you have your local machine and you can have Azure CLI running in your local machine, either inside your PowerShell if it is Windows machine, or you can use the Windows command prompt also. If you're using a Linux-based operating system like Ubuntu, you can install Azure CLI in Ubuntu, just like apt-get. If you're using Mac OS, you can use in the Mac shell that Azure CLI. So Azure CLI is a command line interface which can work in multiple different operating systems, and the experience is uniform. That's the beauty. And then I want to show you the easiest way how you can run this Azure CLI. You just need to copy this. Okay, let me copy it. And Azure comes with this cloud shell. You can see on top, I'm just pointing my mouse, and just next to the search box, there's a cloud shell. There's another way of opening this cloud shell, and I'm going to do that here. And that's what shell.azure.com. If you type that, what happens, it's going to go ahead and open this Azure cloud shell. in a separate browser. It's a browser-based experience. So no installations is required here at this point in time. So let me do it again because I choose the wrong user account. So if you see here at this point in time, I am going to get into this Cloud Shell using the Azure login. Okay, so I need to provide the Azure credential, and what it will do if you're doing it for the first time, it's gonna go ahead and create a storage account, and that's where it will store all the files so that you can come back. You see all your user files are created. This is essentially a container running for you to run the basic utility. All the tools you need to run things within Azure are available. One of them is AZ. That is, as it says, if you type AZ, it shows you that Azure CLI is already installed and configured for you, which means that you don't have to do the installation. If you are using it quite frequently, ideally you should be having that in a local machine. So I'm running Ubuntu 20.04. That's basically Windows subsystem for Linux, and that's running locally in my local machine. Okay, so it's just sort of like a Ubuntu on top of my Windows machine. You can see from the screenshot here, right? So if you just type AZ, I also have installed Azure CLI. That's what I need to do it. Nothing comes by default. I need to install the AZ CLI. You can follow the documentation. There is a single command you can just run, and it will configure everything for you. So this is a very easy installation in Linux. Same thing with PowerShell, same thing with command prompt, same thing with Mac. So if I just run the AZ, and it will just show me the Azure CLI this thing. That means it is fine. It is working fine at this point in time. Now what I can do, I can just run it, and I'll use this rather than I'm using browser. I'll use this window so that I have some stability over here. So you can see that I copied this. What it does, it gets the credential back to my local machine. So let me run it. If I run this, what it will do, it will ask me if I have done it before with the same name cluster. Do I need to override it? Because I've done it to test whether I can connect. So it probably should ask me whether I want to override it. I'll simply say yes, and I'll proceed. What this will do, this will get you all the necessary information about the key, etc. And then you can see that the current context is set to this, to ready to work with this Kubernetes cluster. Now you need another tool to connect to that. That is kubectl. Okay, this is also a tool, command line interface, which you need to run. So if it's already installed, and I have done the installation. So it's again single command you can run, and I ran that, and it installed the kubectl. It is installed. Now the kubectl will allow me to connect to that Kubernetes cluster because I have downloaded that certificate information in my local machine. Okay, so let me run kubectl get nodes. That's the first command you will run. It will tell you about the nodes. Because we don't have anything inside this cluster, we can get the information about the node because we know we have nodes available. So if you get any information which brings you the value of the node, that means you are now connected to a Kubernetes cluster. Whether that cluster is local or in cloud or in some data center, doesn't really matter. You are pointing to a Kubernetes cluster now. It gives you that information. Now you can see that it tells you that the node pool is 5 or 19 minutes old, which means that I have done it much before this demo. Created this whole cluster, tested whether I can do things over there, etc. So it is working fine. Okay. Now one small thing I'm going to do now to reduce the typing is by setting an alias. So I can do that in. So if I say so, next time I don't have to say kubectl get node. I can say get nodes. So it will get me the same output back immediately. So you will see that it's just a quickest way to type things out because I need to keep typing the kubectl. Now, I'm going to spend a little bit of time helping you understand about the kubectl because this is a very important tool when you start exploring about Kubernetes, right? So kubectl is a command line tool to interact with your Kubernetes cluster. It uses the Kubernetes API server and talk to the API through CLI. Okay, you can talk to the API by writing your own code, but that will be too complicated. Okay, so to do common tasks like creating a pod, deploying an application, etc., you can use the kubectl to do that. Now let me show you the very basic kubectl command by creating a simple Kubernetes pod. Okay, now what is this pod is all about? Let me have a quick drawing over here. Okay, so we are talking about a container-based application, an application which is kind of created and containerized, available in some public registry. So assume that you have a cloud, and in that you have that container image available. It can be a website, simple website, and it is having all the code created as a container image available ready with an HTTP endpoint. Okay, that's what we are talking about now. Now, when you have a Kubernetes cluster and you want to use this to deploy a container, now Kubernetes has something called a container runtime internally, which allows you to host the container image. You can do it in normal Docker also. So if you have a Docker runtime running in your local machine, you can download this image and run it. But when you want to do it at scale, you can't really have a single Docker running, so you need some orchestration, and Kubernetes does give you that ability. Now, Kubernetes does not ask you or never ask you to run the container directly. What it tells you to do, it tells you to create a pod. Okay, so just understand the basic difference. And pod can host your container. That's your container. Okay, so you can actually get this image, build a container, and run it. But you never say in Kubernetes that I want to run this container. You always start from pod. So that's the basic building block. Understand this. So this is your basic building block. Okay. So this building block allows you to have more and more containers in the system. Now we'll also understand how we can manage it when things go really complex and large. Then we go one level up. So we'll come back to that later. But this is the primary thing we need to understand. We never run directly a container in a Kubernetes cluster. We always run pod, which internally hosts a container. But we don't say that we want to run this container directly. So let's see. That is why you don't need to know how Docker command works when you work in Kubernetes. You need to know how kubectl works in Kubernetes. So I will go back to this command prompt and I say kubectl. Every time I type k, that means I'm typing kubectl, k run. Okay, and then you give any name. Let's say I give a name of pod 1. Okay, and then you say image. Now this image can be an image from your own repository or any public repository or something like a private repository. Depending on from where you want to download the image, you need it. But if you just give the name like that, it will use the Google public container repository, okay, and get you the Nginx image from there. Okay, so Nginx is a web container, and you can see that quickly it says pod1 is created. That means the command I typed is syntactically correct, but it is not yet created. Okay, and I'll show you why. Okay, so let's see. After some time, you'll find that pod is saying running. So I'll say k get pod. So you can say pods or just po. that will show you the list of pods. So I prefer the short forms because they help me type less. Now you can see that the web and the pod one are running. Both are running fine. So the web is what I tested some time back. So you can see that 5 hours, 5 minutes, just immediately after I created my cluster, which was 5 minutes, 5 hour, 19 minutes old. I created this pod to test out the connectivity. Okay, that's what this pod is all about. But the pod one is the newly created pod, which is having no error and it is running fine. I want to know a little bit more about what this pod is all about. What is this one by one? And what it says about restarts and the status is running. One by one means that it is hosting one container inside this pod. In Kubernetes, you can have more than one pod running within the, more than one container running within the pod, which means that you can have, let's say, more than one pod. Now, containers. So if you have, let's say, 2 containers within a pod, you can have it. So let's see how that looks like inside this pod one container. To know more about this, you say kubectl describe and then you say pod one. If you say so, and the pod one exists in the Kubernetes cluster, it'll get you few more additional information. Okay, so let's just wait for this to bring a little more details. So we need to say pod one. You can see that now it gives you a little bit of information here. So let's go from top. Okay, so this is a name is pod one. Namespace is default. We'll talk about namespace later point in time. But you can see that it is having an image nginx. That's what I mentioned. And it came from this image repository, docker.io. It's a public repository, and that's why it did not challenge me while it downloaded the image. So I was never challenged. There was no error. Okay. And then you can see a little bit of event information about what exactly happened during this process of creation. So it said that started container this. So it will start from top. So it's successfully assigned, pulling the image, successfully do that. Now, I want to show you the experience when you have an error. Okay, so in that case, what I'm going to do is that I'm going to, let's say, run this other window that is our Cloud Shell, connect it to this AKS cluster. So let me get the information. Let me try to run it, or else I can just do it in side-by-side window. That's also fine. But that'll be fun to see if there is any error showing up in the screen almost immediately, because otherwise I'd wait for that. So okay, let me point to the right subscription first. Okay, and then I just run the connection, so it will then download that, and then I say alias k cube cdl, and then I say k get pods. Okay, if I say so, it will be one time. Okay, this will show me the one-time list of pods, all the pods running in this, and you will see that pod one and web, that's the same thing which you have seen earlier. But if I say this with -w, that means I am opening it in watch mode. Okay, so it'll be changing if there is a change in the cluster. That's what I wanted. Okay, so let me run it side by side, and then I run this side by side, and I run this one side by side. So you can see that now I have both the windows running side by side, and I just reduce the font size a bit more. And what I'm going to do is I'm going to create a container with some intentional error. And that intentional error is that I'll mistype the name of the image. So here the image name is Nginx, and I just simply put Nginx1. There is no image hopefully exist in public repository called Nginx1. Okay, essentially you will get a confirmation saying that this pod is already created because I cannot have two pods with the same name. So let me change the name. So that was the first error. But you can see that pod2 created. So it did not say any problem. It did not tell me any issue. But if you look in the right hand side, you see that it started creating the container. That was all fine, but there was a problem. The problem is error image pool, and this is live. This is live in the sense like whenever that error comes, it immediately shows up here. So it is watch mode. So you can see that the error image pool. So it keeps trying that. Okay, so it keeps trying to pull the image just in case there is an intermittent issue. It will still try, right? So it is still finding the error. So let's see inside the pod description, what is the error? Now, I want to point out one small but important aspect to it. If you see that when I ran this, though this image didn't exist, it still confirmed me saying that the pod2 created. Theoretically, it is correct because that's why in the right hand side you can see that it is trying to create. It never say that you have a wrong image name because it still don't know. It happens when you use this kubectl. It calls an API called Kubernetes API server and then takes all the value and checks the syntactical thing. So theoretically, it is correct in a sense that you have provided all the information. But when it tries to download the image, it actually faces the real challenge. And that's when this error comes up. Now you can see that it'll keep coming because Kubernetes keeps trying. Okay. Now if you come over here and say that describe pod2. Pod2 now is in the database, backend database called etcd. That's the heart and soul of Kubernetes. So it's basically the key value pair database, which holds all the information. So all the event and everything you get retrieved later point in time comes from that database. So you see that now this database tells me something different. Okay. So it tells me that there is a problem. So let me increase the size of the screen. So you see that, let me run it one more time. If I run the describe, it'll tell me what is the issue. And that's why we call the describe. Kubectl describe is mother of all troubleshooting. So you start from kubectl describe when you have a problem in the system. So it says that Docker IO library Nginx1 latest failed to resolve the reference. Full access denied. And it could be many different things. It could be the repository may be private. It could be the version number conflict or the level conflict, or it could be, let's say, issue with the name. So it will tell you what is the error. Okay. It says that repository does not exist. So it still don't know yet, or may require authorization. So I said that there could be two scenarios. It may be this exists, but it is a private repository. In that case, you need to provide the credential, and there is a way to do that. So we'll talk about it later, but you just need to understand that what we are trying to do is all public. So it doesn't require any authorization, no login required, so you just simply can get it. So it is giving you also a false error message saying that the authorization failed. It's not the case. The case is that we intentionally mistyped it. Hence, the pod is never created. So if you want to see the latest list of pods, you'll say get pod. It will show you the list of pods, and one of the pods will be problematic one. That's the pod number 2. And you can see that it shows you the image pullback off, And then the status is showing 0 of 1. That means I have one container within the pod and 0 of them are running. So none of them are running. You can see that there is a problem. So let's delete that pod. So we don't need to keep it. We can simply go ahead and delete. If I say k delete pod 2, it will simply wipe off this pod from this database. So it is saying that pod is deleted, and you still do not have that command prompt ready because it takes a while to clear it off. Now if you say get pod, you will have only 2 pods. So you see that I can literally find what exactly went wrong by intentionally doing some mistake. Now there are so many such command prompts available in kubectl. It is really hard for us to remember everything, but there are a couple of ways by which you can play around with this CLI. So every CLI work comes with a very rich set of help options. Okay, one of the options is that to go to the kubectl official documentation and go and use the cheat sheet, so which basically gives you the list of frequently used commands, or else you can use the CLI to get the help. So for example, I was trying to create pod, so I said that k run, but I don't know what I need to pass, so I just simply type it. So it says some error. If I need a help, you see a bunch of things coming up when you say dash dash help. Okay, and I want to walk you through that. So it's from beginning. You can see that you can run this. That's what I did. Okay, I gave a name. I gave an image name Nginx, and it ran. If you have a different image and then you want to enable a different port, you can also explicitly say that port. Now, what all options in that kubectl run command? You have these many options available. Now, in the typical Kubernetes world, we don't use this CLI to create the real production workload. Rather, we use something called a declarative way. That means a YAML instruction. And as you can imagine, YAML can become very complex. Now, kubectl also comes with a lot more nicer capability to help you build those YAMLs not from scratch. Okay, and I will show you that experience also. So let's say what I was doing, and I want to do it through YAML. So I had to build a YAML first. To build that YAML from scratch is something we never do in Kubernetes. We start from something. And that's something you can build by yourself. You don't have to copy it from somewhere else. You can do it by yourself. So let's say I want to do this pod 2 creation, right? So that's what I was doing. And then I want to build a YAML. Now this time, let's put a right image name. And then to test out whether it will work or not, I can use something like dry run client. If I say so, this will not be created, but it will be tested whether this command works. Okay, and it will tell you whether it works or not. And but the actual object will not be created. Okay, it's dry run, as the name suggests. It's just a dry run, but not a real creation. So if you say k get pod, you will find the list of pods. Let's see what are the pods available. And you can see that only 2 pods. The pod 2 is not yet available. Okay, it is a test in the real cluster. Okay, now I want to build YAML. Okay, so to do that, you can always use output o YAML. What happens then? It builds an YAML and gives you that YAML here. Okay, so that's the YAML you need to build the Kubernetes pod. Now in Linux, you can store it to a file. So let's say pod2.yaml. Let's give a name to that file called pod2. Now, if you are using Linux, you use Vim. So I'll say pod2.yaml, and it opens in VI editor. Now that's the YAML we are talking about. Now there are certain values which you can delete or keep. That doesn't really matter. So if you say so, it'll just go ahead and remove this. And I can just remove this, make it a clean one. So I can just leave this basic thing, right? So I can use also remove the DNS policy, restart policy, all these things. It still create the container. But I wanted to highlight two few things. You have the API version, okay? The API version we are using is the V1. The kind is pod. The metadata is about name, level, etc. And then specification is about containers. So you can see the containers. That means it's a collection of containers. So if you have more than one container, you can have more than one container. So if you, let's say, have over here another container, and I say image nginx, and I just name this image as pod 3. So that will make this pod with two containers. Okay. And then if I come out of this and then save and out, it is still not created. I just modified the file. This is a text file. Okay, let's just check whether this pod2 file is created. Now it's there, created, fine. But yeah, not yet this pod is created in my Kubernetes cluster. So if you run the get pod, you still won't find the pod created. Okay, you still have the two pods. To create pod from this YAML file, you need kubectl apply or create and then -f and then say the file name, and that will create the pod. Now every time you're making some changes, you should make the changes in the YAML file, store it in a source control repository, do a check-in, do the versioning, etc., and then deploy, redeploy, do whatever you want to do in that. Now, if I run that, I will find 3 pods running with an error with the second pod. Okay, there are obviously some error because of something I have done stupid. So let's say I get describe pod 2. So it will tell you what is the problem. So there is some issue with this container which is not quite sure what is that. So you can see that image, the pod container created, successfully restarted, but back off, restarted, fail. So there is some problem. The problem, I know it's because I'm using two containers with the same, so that could be a port issue. Okay, so let me go back to that. Here I am pod2.yaml. Okay, and then I just simply go ahead and delete these 2 lines and come back and run here. And then to delete the pod which is created from a file, I can use the same file to delete it. So to delete that, I'll say k-delete -f pod2.yaml, and I'll delete the pod which was there part of that YAML. So it's also easy for me to delete something which I am using to create from a file. I'll say apply pod2. This will not get created because I'll tell you why. I've done the same mistake. So I'll just delete it. And I'll modify the file one more time. And I'll tell you why it is not getting created. There probably is a name pod1, pod2. Let me just see if I have a pod running. Okay, get pod with pod2. No. Okay, that's fine. So that looks fine. Now I come out of this and I run this apply. Now let's see what happens. When I say apply, now let me run them side by side. You can see that the pod 2 is running. This time there is no issue. The pod 2 is running, all fine. Let's see over here as well. So k get pod. If I say so, you will find 3 pods running perfectly fine. You can see that pod 1, pod 2 are running fine. Now this is the YAML experience, the experience through declarative way. So all the thing you need to run over here, you basically modify or put it in a file, okay? And then if you, let's say, want to build another pod, you can just copy the content of it or change it or put it in the same file. You can you can actually create multiple pods from a single YAML file just by putting triple dash to separate 2 different things. So you can have more than, but we don't generally do that. So we create, let's say, each pod or deployment separately. But if you have a deployment and service, which we'll talk about later, you can have them in the single YAML for the better management capability. Okay. So this is how you use the YAML to create a pod. Now, we have 4 more minutes, but I wanted to also talk about something in my upcoming session about deployment, about services through which you actually build the real production workload. Because going forward, in scenarios where you have application running, we don't really create a pod. Okay, we create a deployment which controls the pod, and there is a behavior, which is why Kubernetes is so popular, that it is called as self-healing, which means that if there is a problem, then Kubernetes will make sure that it will take care of the unhealthy pods and then create the new pod, which basically will be available for you. And if you, just in case if you have issues with one cluster, you do not need to manually move those pods from that cluster to another cluster if you wrap them around deployment. So deployment is sort of like a bigger umbrella of things which needs to run on a constant basis in a real production with a monitoring capability. And we will talk about it in our next session, probably in the new year, because I won't disturb you, bother you during the Christmas time. So I wish you all a very happy holiday, and we'll probably plan something in the second week of January when you all probably are back. So thank you very much and have a wonderful day, evening, or night.